Good afternoon. Can you hear me? Yeah. So there's been a lot presented about production, energy production, and some on policy. I'm going to talk substantially about consumption. I want to thank the organizers to organize the event, but also to invite me. And I'm going to give you a perspective on cities. And cities are interesting. There are several themes here which I think are very, very strong. One is that cities provide for a local commitment to addressing climate change. Cities also provide a local result, consequence, that also has global consequences to actions taken to address climate change. And I want to just put cities in perspective a bit. Historically, cities have always been the nexus of intellectual, technological, cultural, social shifts. It's a concentration of all of those things, partly because it's a concentration of the main factors that contribute to environmental consequence, and that is, using the IPAT equation. I'm sure many of you are very well aware of the IPAT equation, environmental consequence related to population, affluence, and technology. Cities provide not only the opportunity to address those in a local way, but also sometimes are the site of early warning for the effects of global climate change. And we've seen many examples of that this morning, from exacerbated heat waves, especially in city centers, to the issues around flooding and storm surge and sea level rise in coastal cities. Because cities are by definition concentrations of these things, I want to just give a little nod of appreciation to the New York Times for having produced these videos. We are becoming better aware and maybe more personally invested in the link between, and it's a complicated link, between this kind of phenomena and what it means for our civilization. And as Carrie pointed out this morning, we have become exquisitely attuned to the climate and therefore have settled vast regions of our coasts. This is just, you will have seen as I'm talking, the consequences for a country like Bangladesh. And so the link between, I think we are past 2015, I've read, is being labeled as the death of denial, the year of the death of the. I think we're past that, and we're now, because these linkages are becoming very, very visceral, very immediate. So I want to make sure that I set the context for cities. Around 1960, total extraction of resources. So this is the extraction of resources from the earth. Around 1960, the total extraction of resources went from substantially renewable resources to non-renewable resources. So the non-renewable, obviously metals and minerals, fossil fuel energy carriers. This is very much a reflection of the vast industrialization of the global economy, in addition to the expansion of the built environment, and mostly in cities. So, the beginning of the 20th century, the urban population was 220 million. The end, around 2008, let me give you 2008, it was 3.35 billion. So there's an enormous explosion in urban population and the consequent resource extraction and consumption needed to serve that. Also 2008, in this graph you can see, marked the crossing of the threshold when more than half of the global population now lives in cities. That's expected to rise to about 60 to 65% in the next 30 years. Upwards of 90% of this population increase is going to happen in the developing regions of the world. So a good bit of my presentation has a lot to do with the developing world, a lot to do with the global south. Accompanying this increase in urban population is an increase. The land use change is important here because there will be a tripling of the built urban landscape by 2030. So the energy landscape is daunting. As we've seen, the climate dynamics are sobering. Today, about 3/4 of energy consumption and carbon emissions can be attributed to urban economies. And closely reflecting urban growth, by 2050, our global demand for energy will double. So the importance for cities is enormous in decoupling high carbon energy consumption and also just more generally high carbon resource consumption, food, water, everything else, from economic growth. Because the challenge that we have is that there needs to be a great deal of economic growth in this increased urban population in the developing world. So let me talk a little bit about the field that I work in called urban metabolism. Very simply put, it's the resource requirements of urban economies. The way that we establish an understanding of the resource flows and the resource intensities of urban economies is we simply equate the entry into an urban space of resources with what stays in and what goes out. So it's really a mass balance equation, but it's also meant to understand the transformation of materials and resources, other resources, water and energy carriers in a city. The main goal of the work is establishing the quantitative, but also the qualitative links to urban population growth and other fundamental aspects of cities. So, some key findings from urban metabolism. I can say that urban metabolism as a field was founded in early 1960s by Abe Woolman, a sanitation engineer. And he wrote in Scientific American an article, a thought experiment, that was for 1 million people, what do they consume? An abstract city of 1 million people, what are the resources they consume and how much waste is produced? So since then, since the 1960s, 1960s, 70s, through the middle 80s, there was a slow burn of work. I'd say in the mid 90s, and especially in the last 10 years, there's been an enormous amount of work in urban metabolism, and there's several different groups working on around the world, and we've reached some key findings on the level of resource intensity of cities. And if you take all of the resources, physical resources required to live in a city, and you put that in a basket and you weigh it, there are essentially 3 kind of large ranges of resource consumption in cities today. One is in the developing world, and the overall weight of those resources, including the weight of the fossil energy carriers, is about 5 tons per capita. It can go as low as 1 ton per capita in the poorest areas within those cities and developing regions, and that is equal to pre-fossil fuel urban settlements, Neolithic and other settlements, which is really a very, very sobering thought. The next range has to do with cities that are found in transition economies, have a good bit of industrial part of the economy already, but they're transitioning into services. Cities like Lisbon and Eastern Europe, the Mediterranean, those go between 10 and 30 tons per capita. And then on the high end, which include European cities as well, even though some of these cities are ranked very highly in terms of their sustainability or their resource efficiency, the floor is pretty much 30 tons and goes as high as goes to about 90. And we think from some recent findings that there are several cities that top out at 100, 120, maybe even 150 tons per capita. So the range of resource consumption today is enormous. And so this is a bit the story of the global south and the global north. So I want to add to this another kind of work in urban metabolism, which tries to get a handle on the kinds of cities that are consuming resources today. And let me just give you an analogy. About 20 years ago, green building work started. So these are just low energy buildings, healthy buildings, all of that. At the beginning of that movement, there was a sort of general green building label. Very quickly into that movement, maybe just a few weeks into that movement, it's very, very clear that there are green commercial buildings, there are green office, there are green retail buildings, there are green residence buildings, and those types of different occupancies, different buildings, require very different strategies. So the question we ask ourselves is, if we have a lot of data for many hundreds of cities, are they all the same, and do they really take does one size fit all? So the way to get at that was to take the data that we had for several hundred cities, analyze that data, and find if they cluster in terms of the way in which they consume resources. So these are 7 different resources and CO2 emissions. This is just a star diagram, and this is really just illustrating low, medium, and high rates of consumption for these 7 materials: biomass, fossil fuel, total energy, electricity, CO2 emissions, industrial metals and minerals, construction metals and minerals, and total materials. Okay, so this is just the hypothetical example here. We arrived at, and sorry, this is not very well, can't see this very well, but essentially arrived in the first phase in 15 city types. And these are those cities. So no big surprises here on the ranges, on the extremes. These cities, as I mentioned before, are very resource efficient because they underserve their populations. These are not really models for the future. Cities up here are at the high end, and Boston is Boston's right there, and Phoenix. They're not up there because they are necessarily resource profligate. They're up there because we simply expect more amenities, more comfort. This is an air-conditioned space. All this heat is getting pushed out. We expect that. So the interesting cities are in the middle, and those are cities of the transition economies, and they may be, some portion of that may be, some type there may be a model or 2 or 3 of the future. I don't want to spend any more time on this because I'm going to go over time, but I do want to move ahead to say these different types are pathways, possible pathways or possible states along a pathway towards urban sustainability. Let me put this in the global context. I really do think with all of my heart and soul, and now as director of the Environmental Solutions Initiative, with the mandate that I've been given, that we are really very much at an inflection point here at MIT, regionally, and globally. And the inflection point is characterized globally by 2 things: COP21, post-COP21. So enough said, I think it's already been talked about. What hasn't been mentioned, I didn't hear it mentioned, were the United Nations Sustainable Development Goals, which go a step further than the Millennium Development Goals, which have to do with coupling a humane future of development with resource efficiency, with low carbon, with a low carbon future, and that's important to me. 7 of those goals relate specifically to cities. I won't go into any of those in very much detail, but cities are very, very much a central player in a low carbon future. And let me just give you one example here. So given the fact that Africa and Asia, I've already talked about population growth, African economies are booming. Between 2005 and 2050, we're going to have an increase of 540 exajoules in urban energy consumption. Now, let me talk a little bit about consumption and the technology. Cities will absolutely depend on technology breakthroughs, but there are also policies and design and planning on the consumption side that can also reduce energy consumption and resource consumption generally. So if you just took 2 policies, increased density, so you promoted density, urban density, and a gasoline tax. This is from a paper from Kreutzig, which is in the latest IPCC report. Through just those 2 policies, you can reduce the consumption by 190 exajoules. And 29% of that can be attributed to reductions that you can apply to Africa and the Middle East. Middle East, by the way, is one of the most rapidly urbanizing places. It is the most rapidly urbanizing place in the world, and we know about the challenges there from climate change. Okay, just 2 more slides, 3 more slides. Given that we launched an African Urban Metabolism Network last year, part of the action is being on the ground. Universities have the incredible privilege of being the long-standing partners with local actors, and in Africa, that's extraordinarily important. So we've developed this network. We have about 50 partners in academic, research, government, and business. The point is to understand better where do resources come from for Africa, how are they distributed, how are they consumed, And so we've coupled Sankey diagrams of the actual resource flows with the geographic location of that resource extraction, distribution, and consumption. And the next step, which we're in the middle of now, is being able to propose alternative modes of satisfying in a humane and sustained and community-based way the provision of critical resources in urban Africa. And this is just a diagram of an eco-urbanist vision for a neighborhood in Lagos. And so I'll leave it there. Thank you.
We have time for a couple of questions.
It's been said by a lot of people that urban living is much more environmentally benign than rural living. I mean, you have public transportation, you have the surface volume ratio of buildings is low, so you have less heat, less air conditioning, less.
So the question is, it's been said that urban living is much more resource efficient than rural living, and that is absolutely true if I take a population of people at the same income level in the countryside, and I put that same population of people at that same income level in the city. Because the thing that cities do the best is create wealth. That's why they exist, actually, because people want to trade and leverage their skills, and that's the way cities were founded, which means that inevitably, with city living and economic development in cities, there's greater consumption, greater material and energy consumption. However, the opportunities are exactly what you outlined, which is that with less surface area, with public transport, with walkability, with more efficient buildings, you can absolutely dampen and significantly reduce that consumption. But the basic question that you're asking hinges on the intensity of consumption, which is most closely correlated with income. Right? Yes?
I'm an architect, and Ed Renteria, Architecture 2030, he went over and was part of a group that the UN recognized for a full day during the COP21. So it seems that's a growth potential for assistance in expanding urban and housing, etc., that the UN is recognizing. Speak to any of that, or?
So the question is, or the comment is that the observation is that the UN provided a full day to 2030 Ed Masrio, which is a very ambitious goal to reduce the energy consumption of buildings. And isn't that a signal of commitment? And it is, absolutely it is. And I think that what's happened is that, I should say that the IPCC very early on identified the built environment sector as the smartest dollar spent, the lowest hanging fruit. So it's been there for a long time. I think what we're getting at now is that the diversified approach between low carbon production and efficient consumption is absolutely necessary. And the building sector is the laggard in efficiency and has a long way to go, therefore huge opportunity there. So I must say, I'm an architect. I must say, there's no better time to be an architect, because the built environment's going to change and could dramatically change, and it's up to us.